this is doing its thing, so we are ready. Any questions for me, please? Today is the 5th, isn't it? So let's start with your questions. Anything you have for me? Oh, of course. Logan just told us. Okay, so this is, we are back to 1.6. We want to look at another equation. Oh, we didn't finish, actually. We have the absolute value equations. So we want to look at another equation that is quadratic in form. Oh, here's an example. 48 on page 185. So this is x to negative 2 minus x to negative 1 minus 6 equals 0. This is an example. And if I ask you what type of equation is this, you don't know exactly that it's quadratic in form, but you will know that it is also part of another category of equations. Which category of equations? Can anyone tell us how to write x to negative 1? Say it again. Excellent. X to negative 1 is 1 over x. Excellent. So then this is negative 1 over x minus 6 equals 0. And what about x to negative 2? Thank you very much.
Negative 2 over x?
If x to negative 1 is 1 over x, what do you think x to negative 2 can be?
2 over x.
Say it again.
2 over x.
Okay. Okay, so it's confusing because this is 1. X to negative n is 1 over x to the nth power. So please make a note of this. Put it in your notebook, in the tiny notebook. Any expression raised to a negative exponent is 1 over the same expression, but positive exponent. So then coming back to x to negative 2, I understood the confusion. X to negative 2 will be? Excellent. So what type of equation is this now? Excellent. It is a rational equation. We will not treat it, though, as a rational equation. We can. Nothing wrong. But we are trying to practice a different method. So I'm looking at x to negative 2 minus x to negative 1 minus 6 equals 0. Okay. Which of these two quantities I'm going to look at and say, maybe I should say let be, I don't know, t. But what? Or let t be that. What quantity you think? Just give it a shot.
X negative 1.
Excellent. If this is t, is there any chance to replace this by something else in terms of t? I can have x and t in the same problem. I will not be able to solve. What do you think?
X t to the second.
Yes, of course. Otherwise, the method is not applicable. But is it true? Yes. Because if you square both sides, you get x to negative 2 equals t squared, of course. So if we denote x to negative 1 by t and square both sides, we get that t squared is x to negative 2. Can anyone now dictate the new equation that we are trying to solve? And the new equation is in terms of t.
It's t squared minus t minus 6.
Good. Now we know we have no secrets here. And we will factor how? No, not with 3 terms. The sum is negative 1. With 1 and 6, I will not get a sum of negative 1. But you're on the right track, of course. But the sum is not going to be -1 with 6 and 1. 2 and 3. I agree. So this is x minus 3 and x plus 2. So there are two options. X to b and x to b.
Just put the x back in, right? In place of the t.
Oh, I'm sorry.
That's okay. I was just making sure.
No, you're correct. I was wrong. My apologies. No excuse. Of course, I'm still working on t, not x yet. Sorry. My apologies. So we have two answers for t. 3 and -2. And now we have two more equations to solve. Can anyone dictate the new equations we need to solve? T equals 3 represents, and t equals -2 represents a new equation. Two new equations. What are they? What is the first one? T equal, x to -1 equals? Very good. And, of course, you're correct. Perfect. Now, how do I solve this? And, of course, that. Well, I have to change it back into a fraction. I have no choice now. So, one more time, what is x to -1? Very good. Equals 3, or 3 over 1. And how do we call this? Very important. How do we call it? Two fractions equal to each other. How do we call this? Proportion. Very good. Very important to remember, because only in a proportion we can do what? Good. So 3x equals 1, x equals 1/3. The second equation, how do I change it, or what do I change it into? Equals -2 over 1. Same thing. You can only incorporate the negative with one side or the other, not both. I'm going to say -2x equals 1, not both. So x equals -1/2. And here are the solutions. Any questions, please? Anything? So this is how equations quadratic in form are solved using a substitution. Okay? Did you have to do this? No, you could have solved it as a rational equation. You would have gotten the exact same answers. Of course. But we wanted to practice the method of substitution for quadratic in form. Last type of equation, are we ready for that? Yes? Absolute value equations. Absolute value equations are not linear equations. So let's start with, no. 1.7 is inequalities. Not yet. Absolute value equations, let's start with a very simple example. Let's say the absolute value of x equals 7. What does this say to us?
Distance from 0.
Exactly. Find the numbers whose distance from 0 is 7 units. Find numbers whose distance from 0 is 7 units. That's exactly what this equation is asking us to do. Find the numbers whose distance from 0 is 7 units. Okay, so remember the real line, 0 is here. Where will I find numbers whose distance from 0 is 7?
7 and -7.
That's it. So this equation then has two solutions, -7 and 7. This is the idea behind absolute value equations. Of course, there are several situations. I just want to mention a couple. In this particular situation, how many solutions did we find? 2. Here's another example. How many solutions do you think this equation will have? How many numbers have the distance from 0 units? Just 1. Good. What about this one? The absolute value of x equals -3. How many solutions will I find now? Before you answer. Correct. Before you answer, I'm telling you that the distance between me and Chris is -10 feet. Is that possible? No. So here are no solutions. This is always a positive number. This is a negative number. I can never set equal a positive to a negative. No solutions. And there is a fourth option in which, like, for example, we're not going to solve them because I didn't see any example in your book. This equation has infinitely many solutions. So absolute value equations, the point I'm making here is that they are not linear equations. Look how many different options we have. 2 solutions, 1 solution, no solutions, and even infinitely many solutions. So I'm going to pick a problem. You can pick if you like. We are on page 186.
It says,
Yes?
the first one says, absolute value of x equals 0 equals x equals 0. What is that?
There is only one solution. Only the absolute value of 0 is 0.
I just couldn't read it, that's all.
Oh, sorry.
I just want to make sure it said 0.
Yes.
I saw it, but I want to make sure. Okay.
Yes, of course. Sorry about that.
It's okay.
Yes. So let's take a look at the following example, like 67 on page 186. And this is 2, quantity 3x minus 2 equals 14. I specifically chose this problem, or this equation, just to remind you that the absolute value symbols are not grouping symbols. Or absolute value symbol is not a grouping symbol. What does that mean? You cannot distribute. That's not allowed. You cannot take anything outside and factor out. That's not allowed. You have to treat it as a concrete block. You can't touch it. You can break it. You can do anything to it. Then what? Well, I have to clean it up. Remember the 2 keywords, factor, simplify, those should always be on our minds. I can still clean it up, even if I can't touch this. How? Absolutely, thank you very much. So I know who's watching my videos. So 3x minus 2 equals 7. Awesome. Now this is back to the original type of problem, right? In which I'm asked, find these numbers whose distance from 0 is 7. What can I put in here? Can I put 3? No, I can't, because the absolute value of 3 is not 7. Can I put 10? No, because the absolute value of 10 is not 7. But what can I put in here? That's it. So this quantity, what quantity? This quantity, 3x minus 2 could be 7, or 3x minus 2 could be -7. These are the only options. Is it done? No, because I haven't solved for x yet. But that's the first step. If we don't remember how to change this equation into these 2 equations, we are not going to be able to solve. This equation changes into these 2 that we can solve. Otherwise, we cannot touch this. We cannot do anything to it. We have to remember to change it into these 2, and now we are ready to solve. I'm adding 2, dividing by 3. I'm adding 2, dividing by 3. Do these steps at your leisure, or using the methods you like. And I'd like to look at another. Any questions, please? And these are the solutions. -5/3 and 3. One more time, we added 2. We got 9 divided by 3. We added 2, but negative 7 plus 2 is negative 5, and we divide that by 3. Is that okay, everyone? Okay. Let's look at another absolute value, and then I would like to look at a word problem. So let's say 71. Same page, 186. 2. Absolute value 4. Minus 5 halves x plus 6 equals 18. Again, remember, we can touch the absolute value, but we can clean it up. How do I clean this up? Of course. Subtract 6. Or move, the same thing. Awesome. Still not cleaned up completely. What now?
Divide by 2.
Of course. Thank you very much. Now I'm back to the first situation. The simplest type of absolute value equation. It's all cleaned up. There's nothing I can do. Notice we did not distribute. Notice we did not add 4 to 6. Do not try anything. It's not going to work. Good. So then there are 2 options here. Can anyone give us the 2 options? Excellent. Exactly. So these are the 2 options. Now these are 2 linear equations. Right? The absolute value equation changed into 2 linear equations. And now let's solve for x. I recommend first subtract 4. So then negative 5 halves x equals 2. 6 minus 4 is 2. And then multiply by the multiplicative inverse of this. So we can get rid of negative 5 halves. What is the multiplicative inverse of negative 5 halves? But negative, right? Negative 2/5. Very good. All this disappears. I only get x. But now let's multiply 2 over 1 times 2 over 5. 2 over 1 times 2 over 5 is how much is 2 times 2?
4.
1 times 5? Good. That's our first solution. We repeat the process, but careful, the signs are different now on this side. We still subtract 4. But this time we have negative 10 on the right-hand side, and we still multiply both sides by negative 2/5. All this disappears, except x, of course. Now we multiply 2 negative numbers on the right-hand side. What will be the sign of the outcome? Excellent. Great job. And now I have to multiply. I prefer simplify. When I simplify 5 with 10, yes, of course. So then the answer is 4. Excellent. Yes, Kayla, go ahead.
In the first one that you did you
You mean
subtract 4?
you mean this
No,
one?
Yeah. Did you subtract 4?
6
from
minus
6
4
to
is
get
2.
to?
Of course.
Okay.
I have to do that first. You can say, I don't want to do this. I want to multiply both sides by the least common denominator, which is 2, eliminate the fractions, and then take it from there. That's fine.
Okay, and then where did you flip the fraction so you cross multiply, right?
We're still talking about the first one?
Yeah.
So the negative 5 halves gets to be multiplied by negative 2/5 to get 1.
Right. To get x by itself.
Yes, exactly.
Gotcha.
So if I multiply this side by negative 2/5, I have to multiply that side by negative
Right.
2/5.
And that, well, how did you know to do it by, what was that called again?
Multiplicative inverse. Okay, let me explain that. Very good question. So a quantity times another quantity equals 1. If I know this one has to be the multiplicative inverse. So if you tell me 5, then I'll say 1/5. If you say 5, I'll say 1/5. If you say 2/3, then I'll say 3/2. If you say 1/7, then I'll say 7. So if I have -5/2, I have to multiply by -2/5 to get the 1. To get 1, yes.
Okay.
Because these two go away, these two go away. Minus times minus is positive, and I get the 1.
Okay.
Better?
Yeah.
Perfect. Thank you. Okay, so in this section, we looked at 3 different equations. Polynomial, radical, absolute value. Actually 4, sorry. Equations that are quadratic in form. And I have one more. I don't want to forget. Yes, there is one more. Last one. Before we look at word problems. Equations with rational, or if you want to call them fractional, exponents. There is a formula in the book. If you want to use it, I am absolutely in favor, but I will never use it. So, because I want to show you a different and an easier method, I think it's easier. But you may say it's not easier, so I want to use that. So that's fine too. Okay, 34 on page 185. X plus 5 raised to 3/2 equals 8. A few minutes ago when we looked at an equation that was quadratic in form, we turned it into something as simple as we could, and we said, okay, it may be quadratic in form, but it's also rational. I have to agree. The same thing here. Do we know what 3/2 represents? Now, we refreshed our memory on x to -2 being 1 over x squared, or x to -4 being 1 over x to the 4th, and so on and so forth. Now, if I ask you how do you rewrite the cube root of x squared, you will say x to which power? Careful. The index is always the denominator. So it's 2 over 3. So every time I see a fractional exponent, what does this really mean? How do we call this? A radical, right? So if I have a negative exponent, I know it's a fraction. If I have a positive exponent, there is nothing I can do to it. That's it. But if I have a rational exponent, it's really a radical. But this is what I have here. If I want to rewrite this equation, how will I rewrite it? Because it,
X plus 5.
so the square root of x plus 5 raised to,
Sorry.
yeah, it's 2 over 3, right? 2 over 3. 3 over 2. 3 over 2 equals 8. So you could say, I don't care for your rational exponents equation. I'm going to turn it into a radical. I'm going to solve it that way. That's fine too. But I need to show you a different method. And you choose the one you like. So basically, this is a radical equation. But it's also an equation that has exponents on the variable. This is the variable right here. It has exponent on the variable that is a fraction. It is radical, but also an equation with a fractional exponent. Okay, so here's what I recommend in this situation. I'm going to copy the problem. You don't have to copy it again. I just wrote too much on the side there. I recommend first eliminate the denominator and then eliminate the numerator, and you will never make a mistake. So number 1, eliminate the denominator First, what denominator? The denominator of the power, of course, the fraction, this fraction that we have as a power. And in number 2, eliminate the numerator. Second. First, the denominator. Second, the numerator. Okay. What should I do to both sides to eliminate this?
Square.
Yes, thank you. I have to square both sides. Remember, I square, I have to check, right? When I square, what do I do with the exponents?
K by 2.
Exactly, multiply. Excellent, very good. So 3 over 2 times 2 over 1, that's why I squared. So I eliminate the denominator, so the power is 3. So then we have x plus 5 to the third power equals 64. Great job. So now we are in the second step in which we want to eliminate the numerator. How do I eliminate this power? What do I have to do to both sides? It has to be done to both sides at the same time.
Degree 3.
Yes, you're talking about the cube root. It is degree 3, so I need to multiply the power by 1/3. That's why I need the cube root. The cube root is power 1/3. What do we have on the left-hand side? What do we have on the right-hand side? I'll tell you the cube root, that's 4. Because 4 times 4 is 16, and 16 times 4 is 64. Well, what now?
Minus 5.
Yes, so then x equals -1. Of course, it comes with a question mark. And I want to go back to the original problem. So I want to show you, I'm not a super fan of calculators, but I want to show you how to, when they're useful, they're useful. So here's how I would check. A left parenthesis. I don't have to write this, but let's write it from the very beginning. So I found that it's -1. We know that -1 plus 5 is 4, but never mind. Okay, then power, and then in parentheses, although I can show you a different way as well. What is the power that we had on x plus 5? Over 2. So 3 over 2, close the parenthesis. And now when I hit enter, if -1 is correct, what should I get? Indeed, awesome. If I don't get 8, something is wrong, or I made an error somewhere, who knows? Here's another option that I personally never use. In math, if you click on math, you see that the new sophisticated calculators that you have the option of the cube root and have the option of any root you want. So once you click on 5, for example, it pops up with any root you want. Let's say the 6th root of 100. And that's what it is. I will never do this because I don't want to go into math. It's too much trouble for me. I prefer 100 caret 1 divided by 6. That's what I like to do. It's too much clicking for me with math and scroll and find 5 and come back and write a number, put in the index. I prefer 100 raised to 1/6 versus the other route. You choose the one that works for you. Good. Going back, I would like to work on one more problem on this. Please ask if you have any questions, please. Any questions for me? Okay, let's take a look at, let's say 38, because I want you to see the difference. So, of course, the difference, first of all, is the power is different than the number on the right-hand side. So there are a lot of differences. But what I'm getting at is this. What was the power here? What is the power here? Right. Thank you so much for paying attention. It makes me very proud. It really does. So when the power, I know, I have to motivate you. I'm really happy. I'm really happy. I know you are adults and I should not even think of those terms, but it makes me happy when you pay. Okay, so you will see the difference what happens in this case. And that's what the formula that you will see in the book comes from. I personally don't care for it because I don't want to just ask you, memorize this, memorize that. So that's what this is all about. This is the formula. If you want to read it, please do so. The method that I'm showing you, you don't have to memorize anything other than eliminate the denominator first, eliminate the numerator second, not the other way around, because you're not going to get the correct answer. If you remember that, you don't need any formula. Okay, so we just said that we are going to eliminate the denominator first. Which denominator? The denominator of the power. How do I eliminate the denominator of that power? In other words, no. Very good. A very good point. Very good point. If you do it in one step, you are not going to get the correct answer unless you're very, very careful. So that's why I recommend do it in 2 steps. How do I eliminate the 3, which is the denominator of that power? I take both sides to the 3rd power. Okay. What is left on the left? X plus 5 to the, yes, equals, again, we had 4 to the 3rd, which was 64. Now, I am back to the previous section in which we solved quadratic equations. What method is the best to be applied here? The best method. Right. How many solutions will we get? Careful. Exactly. Very good. Awesome. So this is x plus 5 equals 8. Great job. And then x equals negative 5 plus or minus 8, and we have 2 options. We have to separate them because they can be simplified. And the negative 5 plus 8 will be, and the negative 5 minus 8 will be, okay? So, of course, we raised both sides to the 3rd power. Both solutions will work because we raised it to the 3rd power. But we should always go back and check, but I guarantee you these 2 work. Now, here's what I wanted to show you the difference. So x plus 5 to 2/3 equals 4. If you know what you're doing, and then you remember that there are 2 solutions, then you can do this. But it's very, very problematic because you will forget to put the plus or minus in front. So please do not perform this operation in one step. Yes?
I forget why we took the plus and minus.
Because it's quadratic and it has to have 2 solutions. So that's one of the methods. That's the second method from the 4 methods that we studied about quadratic functions, quadratic equations, of course, right? So that's the second method. We have to find 2 solutions if it's quadratic. So be very careful. I do not recommend this method because you will forget to put the plus or minus. You will not know why. Why would I put a plus or minus if I raise to 3/2? So please do not use this method. Okay? Good. Next question. Anything else? Okay, this is the end of types of equations, and we have 2 more types in chapter 4. So we're done for now with equations. Okay? But I'd like to look at a word problem. Let's look at problem 110 on page 187 before we move on to inequalities. We are given P. It says the percentage. I'm going to write it as a function, SP of t, 1.6, the square root of t plus 62. I copied the problem. And now let's read it together. No, I didn't copy the problem. I copied the function. Okay, so we have the formula that we just copied. Models the percentage of jobs in the U.S. labor force, P, held by men, T years after 1970. What does that mean? I have to take notes as I read. What does T years after 1970 mean?
The P, is that an exponent or is that just there?
Which one?
No.
The P.
The-
Is that an exponent?
P?
Yeah.
It's the name of the
No,
function.
the P, that you have the, is that like a
So it's like f of x.
Oh.
F
I thought it was-
of x, we have P of t.
It just looks small. It looked like
Yes, it's lowercase p. You're right. It's lowercase p. That's how they denoted it. So we are told that t is the number of years since 1970. What does that mean? T equals number of years since 1970. How much is T for 1970? Number of years since 1970. So 1970 represents T equals. For someone born in 1970, how old is that person? How many years old is that person? Somebody was born on August 1st, 1970. How old is that person in 1970? How many years? Of course. Of course. 0 for 1970, right? 1971 will be T equals, yeah, and so on and so forth. We need to establish that when we read the problem. That's a very important step. Use the appropriate graph at the bottom of the previous column. So let's take a look. Here it is. So we have a graph here. It says, use the appropriate graph at the bottom of the previous column to estimate the percentage of jobs in the U.S. labor force held by men in 2010. I see 2010. The blue graph is for men. So what will you estimate? Obviously, I see it. It's somewhat, it's definitely above 50, right? It's definitely below 55. So you would say 52, maybe 53, roughly 52? If I'm fine with 52. Perfect. So our estimate from the graph, and that's part A of the question or problem. Okay, so in part A, we will say from the graph, we read 52%. Remember, P is percent from the labor force. So from 100%, 52 in 2010, 52 were men and 48 women, according to the statistics. Okay, part B. Use the mathematical model now to determine the percentage of jobs in the U.S. labor force held by men in 2010. So this time, in part B, they want us to use the given model. This was given to us. A lot of effort was put in this to find it. It's not easy to find such a model. Okay, so they want us to use the model now to determine what the model is given. We know the exact data says 52% because we have them. They researched it, they calculated, they studied it, and I came up with 52 that we read from the graph. But they want us now to find the percentage into a 2010 using the model. So, any suggestions? How do I do that? Any suggestions? I know you know. I have no doubt. So this is in 2010. So how do we perform a calculation using the model for 2010?
T would equal 10.
Exactly. Very good. If 1970, that's why we established T equals 0. That's why I tortured you with that, then you smiled, and now you know why. Good. So what do I do now with 40?
You just have to put it in
Excellent. Thank you very much, Chris. So here it is. Negative 1.6, the square root of 40 plus 62. Let's see what we get. Here it is. In y, no, we don't need that. So we have negative 1.6, the square root. For one simple quantity, there is no need, but you already know me. I love my parentheses. And then plus 62. Here it is. Look at that. 51.88%. So now the question was asking us, is this a good model? It's a very good model, but for 2010, I don't know if for the other years it works that well. I have no idea, but definitely for 2010, yeah, I like it. We read 52 from the graph, and we got so close to 52 that I'm happy with the tiny error. Okay, so it's a good model for 2010. I can conclude for the other years because we haven't checked. Last question here. According to the formula, when will 49% of jobs in the U.S. labor force be held by men? What do I do now? Excellent. 48, or did I say 48 or 49? 49. Thank you. Awesome. Great job. Thank you. So this is T. I was going to write X again. Very good. This time we were given the percent to find the year. Excellent. Okay, let's look at this and decide what type of equation it is and decide what to do. Of course. Thank you very much. So is it negative 13? Correct me if I'm wrong anytime.
Yes.
Thank you. Good. So one step closer to clean it up. It's not cleaned up yet. It's not completely cleaned up. What is my next step?
Square.
Not cleaned up yet. By? Yes. Exactly right. And now we do square. So how much is T? I don't know. Parentheses. 13 divided by 1.6. Close the parenthesis. Ah. I didn't take my first parenthesis. Sorry. Okay. And now I want to square. 66 years. What does that mean? When? When will women overtake the percentage of men by 1%? 51% in 19? I'm sorry, in 2036? 2036 it is. Very good.
Can you divide it by 1.6 if you keep positive?
Yes, when I divide two negatives,
Oh, yeah.
because otherwise the square root of t, we're going to be in big trouble,
Right.
right? The square root of t cannot be negative. Very good. Okay.